Good morning students. Welcome to the Science 1 class. In this video, we are going to learn about Avogadro hypothesis and applications of Avogadro's law. Avogadro hypothesis. Avogadro's law was proposed in the year 1811, and the law states that the number of molecules present in equal volume of gases in different condition. That is, this law relates the number of molecules and the volume of gas. The Avogadro's law states that equal volume of all gases under similar conditions of temperature and pressure contain equal number of molecules. For example, whatever the gas it may be, whether it is helium, oxygen, water molecule in vapor state, ammonia gas, etc. When we maintain similar conditions, that is, the same temperature and pressure, the number of molecules present in them will be the same. And this theory was explained by the Avogadro's law. If the number of molecules increases, then the volume will increase. For example, if you have 10 balloons, it will occupy lesser space, and you can place them in a small container. In case, if you have 100 balls, it will occupy more space. Then, you may require a bigger container with more volume. That's why it is said that the number of molecules N is directly proportional to volume V. What is directly proportional? When one amount or quantity increases, another quantity also will increase. And here, when the number of molecules increase, the volume also will increase. To remove this proportionality, we will usually add a constant. That is, V is equal to constant into N. Hence, the mathematical representation of Avogadro's law is V is equal to constant into N. So, remember that Avogadro hypothesis relates volume and the number of molecules. Now, let's see an example. Let's take hydrogen gas and chlorine gas to form hydrochloric gas. When you take 1 volume of hydrogen gas and 1 volume of chlorine gas, you will be getting 2 volumes of hydrochloric acid. What the Avogadro's law states? Volume is directly proportional to number of molecules. So, when the number of molecules increases, volume also will increase. According to Avogadro's law, if 1 volume of a gas is occupied by n number of molecules, I'll repeat, 1 volume of a gas occupied by n number of molecules. Just now we learned that 1 volume plus 1 volume gives 2 volumes. You know that 1 volume occupies n number of molecules. So, n molecules plus n molecules will give 2n molecules. In the above example, 1 molecule of hydrogen and 1 molecule of chlorine combines to give 2 hydrochloric gaseous molecule. What is N? Yes, number of molecules. If N is equal to 1, then 1 molecule plus 1 molecule gives 2 molecules. If N is equal to half, then half molecule plus half molecule gives 1 molecule. From this example, it is clear that there is a relation between number of molecules and volume. Next, we shall learn about applications of Avogadro's law. The first point is, it explains Gay-Lussac law. You have learnt about Gay-Lussac's law in class 9. Now let's have a quick recall of it. For example, let's take a balloon and immerse it in the cold water. What will happen? The balloon will shrink. In the same way, if you place a balloon in the hot water, the balloon will expand. From this experiment, we can understand that when we increase the temperature, the volume increases. When we decrease the temperature, the volume also will decrease. So, when the temperature increases, the volume also increases. How it happens? Because there is increase in the number of molecules which causes the rise in volume. This is the concept of the Gay-Lussac's law. Hence, it is said that Avogadro's law explains Gay-Lussac's law. Hot air balloons work on the principle of Gay-Lussac's law. The second application is, it helps in the determination of atomicity of gases. It means that using the Avogadro's law, we can find the atomicity of gases. In the earlier videos, we have learnt in detail about atomicity. What is atomicity? Number of atoms present in a molecule. For example, what is the atomicity of oxygen molecule O2? Its atomicity is 2. What is the atomicity of ozone molecule O3? Yes, its atomicity is 3. The third application is, molecular formula of gases can be derived using Avogadro's law. For example, you know that the molecular formula of oxygen is O2. Even this molecular formula can be proved using Avogadro's law. The fourth application is, it determines the relation between molecular mass and wafer density. Students, in the next video, we will learn in detail about the fourth application, that is, relationship between wafer density and relative molecular mass. That's all for today's class. In this video, we have learnt about Avogadro's hypothesis and applications of Avogadro's law. Thank you, students. Have a good day.